जा रहे हो क्या? बाहर जा रहे हो?
Hello everyone. I'm audible. Yeah. Okay. So we'll start with my introduction. My name is Anirban Chaudhary. I head a tech company which works on IoT called Frugal Labs. I'm audible to everyone. Any sound issue if you are getting, just let me know so that I can fix it fast. I'm getting a mixed scenario. Can anybody confirm?
A little bit fluctuations are there. Just check with the internet once.
Okay. Just a second. Is it okay now? That's better?
Yes, now I think it's better.
Okay. Okay. So I'll just start my presentation. Okay, so I will give you an intro about myself. My name is Anirban Chaudhary, and I head a tech company called Frugal Labs. We work on connected device and automation for agriculture and agri-related industries. Okay, so I will tell you about my IoT career or IoT journey. So we were one of the initial companies in India, or just to say that we started IoT way back in 2013, 2014, when it was just a buzzword around, and we developed a lot of products, a lot of training, a lot of lab setups for IoT in the full course. And from 2018 around, we are working on devices which are directly connected in remote locations, and they mostly into agriculture or spaces where we have to employ devices and sensors in remote locations. So that is our major work. You can go to our website and check out Frugal Labs. It is. So for this training, the idea, you had 7 to 8 days of Python, and after that the IoT flavoring also, we wanted to keep it in the Python angle only. And keeping that in mind, we'll start with a very basic intro of IoT, where I will just ask you questions about it, and you have to give me the scenarios. Okay, so let us good evening, virtually good evening. Yeah. So I will start with this. This is, so to understand IoT, or what IoT is, we need to understand, first of all, what are the phases of internet, because IoT stands for Internet of Things. I'm just going to my main screen. Yeah, I'll just go one by one, so you are able to I'll just stop sharing. I will just again share so that I can share the exact. No, I'm not able to separately share my screen. So for comments, I have to come here. Okay. So the phases of internet, that is a very important part to understand how we have come to this, where we have connected devices and internet connected sensors all. So the first and foremost scenario for internet, which was very much was designed and developed by American defense industries, and because of that, it was a major thing which they understood that during the World War II, that internet is very much required. I think you have heard these stories, but I'm just repeating it one more time so that you are in sync with the full process of why we have come to this as things and people and information, what I'm showing you. So what they understood that they have to connect, they have to go into a next level of communication, because if you heard about or if you read about stories from World War II, you will understand that information sharing was the major issue. They used to decipher it, cipher it, and then they have to have agents who will take the information. They will have those telegraphs they will send. It was a huge work to do for simply sending some small information. So the American defense industries, they understood the issue, and they thought that we'll connect all the computers and the current computers, which were like very big machines that time, and we will share information between these computers. So while sharing information, so that it becomes easier to, we don't have to do as much work as we had to do with the normal communication till that time. Okay, so that was the initial requirement for the internet. So internet was developed by DARPA, we all know that, and then it was slowly it came into a commercial usage view, but that also it was limited mostly to the universities and graduate students who were doing research, and they were sharing their research and all. So that was the major chunk of the information and communication part of that. That was the first phase, I should say, for internet. So what we were doing there, we were doing information, we were sharing through making websites. So a website is nothing but whatever information you have, you're sharing it to the world. That is your website, right? Agree to my point? You understood these 2 points, website and email? You have to write some messages. Yes, sir. Okay. Shanjona. I think I'm pronouncing your name right. Yes, sir. Okay. Okay. So information and communication. So this was the major thing for which the internet was envisioned or started, I should say. Yeah, Umay, I can see. Thank you, Umay. Yeah. Okay. So that was the main reason, communication and information. So information was, if you give an example for information, that is website. And if you give an example for communication, that is email. That live broadcast messaging was not a part of that initially. It was only emails. Through emails they used to communicate. And that time it was much more different than what we know email in today's world. It was not that much encrypted. It was easy to hack. It was easy to, so that was the phase of communication, information and communication. This was there up till around, you can say up till close to 90s. If you see, close to 90s, we had this information and communication as a major chunk of internet. Now comes the second phase. It is a later 90s, I should say, where, so first one, I should say, internet of information and communication. That was the first phase. The second phase, when it came as internet of people. How people is what we know social media today. It started around 2000, starting of 2000. Google came into existence that time. Gmail also became very normal. We had Yahoo Chat. We had I think G Chat, or I'm just not remembering. I think G Chat it was called. So there were a lot of this chatbot type of things came, and then the social media, we had Orkut, then Facebook came into existence, and then from there we have YouTube, we have Twitter, we have Quora, we have n number of things now. Okay, so this is, you can see see some examples here. I've just put some images. So this was the people era. This actually was the major thing till around 2010. So what is the difference between the communication and information and internet of people? Anyone can give me a one-liner for that? The two phases, that is the information communication, internet of information for an internet of people. What is the difference between the two? If anyone can give me a one-liner. Just whatever you think. Means what is the difference between when we only had websites and email? I don't know. I know many of you were not present that time when we had that phase. But if I think you can imagine that we just had websites and email. Update in technology. No, not only update. See, it is internet. You should not think internet as a technology as such. Means it is a technology, but it always has a real world implication. One-way communication. Oh, very good, Bindya. Very nice answer. One-way communication. See, information and communication was mostly one-way. This is a good point. One-way communication, I will not say exactly one-way, but information was one-way. Communication we were doing to and from. But when people came into existence, something changed. What is the difference? If you think today that you are just working on your emails and website, now we have two-way communication. No, two-way communication is there. In email also, you can have two-way communication. It's not about communication there. Information and communication we have covered in the first phase of internet only. It got much better, it evolved, that is different thing. But people were never part of the internet that time. It was mostly used for information and communication. When people get involved, what is mean by people? So internet of people here, I mean that the internet cross-platform application get developed, time, Manjunath says time and cost to send information. No, you are not getting the non-tech version of it. I'm not asking for how the technology evolved, and those things we can always talk about. But what is the systematic change which happens in this phase? If you can tell me. I will just wait for one minute more. Just think around, not from the tech angle. How internet changed from internet of people gives chance for user response. Okay. People got connected. Yeah, digital to analog, people got connected. This is Bindya. Nice answer. Better communication, Tushar. More personalized. Okay. Now give chance for user response. Siri to me. That is also right. Yeah. So I think you're getting in the right way. So what happened here is let's see. Okay. So what happened with internet of people? See, before internet of communication or information, whenever we were sharing the information, whenever we were communicating, we have to do it physically, or we have to write it in a letter. That is also physical thing. So when the internet came into existence, these things became online. Online means there was no physical thing as such. Similarly, when internet of people came, people used to interact or showcase themselves also. Not only interact, they used to showcase themselves as people. They used to showcase themselves as people on internet. Before that, if you want to meet and greet someone, or you want to know about someone, if you want to know about someone, or in the sense means know about their day-to-day life, and it's what we used to do when we meet people. So this meeting of people became online, or the internet started making people meet there, know about each other in a more personalized manner, and not as an information directly. Okay, you are 6 feet tall, your weight is 70 kg, your eyes are brown. Not like that. That is information. It was in a more personalized way. People started sharing themselves rather than just the information. Sharing themselves means they were sharing pictures, they were sharing opinions. Okay, they were sharing in their life, whatever is happening in their life, they were sharing it. Whatever they think, they were sharing. And still, see, all these three phases are not individual. Communication and information and communication also evolved. Internet of people also evolved. And after that, the third phase came into existence. So what do you think about the third phase? What is that third phase? Can anyone give me the idea that Internet of Things, what is Again, in one way, digital communication, no paperwork. Digital communication, no paperwork was the first stage only. The communication and information, Nishan, and people interacted virtually. Yeah, they started interacting, communicating, and interacting are similar words, but they started knowing each other digitally. That was the major change. So, anything on the things part? What is the things different from the information, communication, and people? The third part of internet. Machine, okay. 1 second, let me see. Providing internet of things rather than computer, laptop, or mobile. Machine, human communication, AI based, video calls, more personalized. Video call is more part of the people part, not the things part. Communication while being virtually present. Yeah, this is again part of Manjuna. This is part of the people thing. More personalized. We just stand and turn on the fan. Yeah, that is communication among machines without human interaction. Okay. So now I will just give you a very basic kind of understanding of what are things. So now, till now, the internet was more on information, communication, and people. Now, mostly this information and communication was also part of the people sector only. So it was human who was at the center of internet. Now, with Internet of Things, see, Internet of Things is a coined word around 2010 or 12. I'm just not remembering the exact timeline. Someone coined it in Europe. It was around 2012, I think. Yeah. So it was coined around that time. And what happened with Internet of Things is that suddenly, see, there was a thing called M2M. There was a thing called, 1 second, I'll just. Yeah, there was a thing called M2M. Okay, so M2M was what? It was machine to machine communication. Okay, so this was already happening in a factory. There were machine to machine communication happening for a little farther places also, but they started coining this as this machine to machine was a separate thing from. It was not part of internet communication. It was not part of people. It was a separate thing. Now, when all these things, when M2M, information, communication, and people, all three come together, then it becomes Internet of Things. Okay, it's Internet of Things is not automation. It's automation also is a part of Internet of Things. Automation is not Internet of Things. Okay, Internet of Things only happens or things come into the internet phase when the things are part of the people and people and information and communication. Okay, that time it becomes I will just see what you guys have written. Machine to machine, smartwatch. Yeah, examples we can all give now. Something like automation. Automation is a small part of smart things. It's like till now people were communicating. Now things will start communicating. Like I will give you example. Let's say we have a thing called smart door. Okay, what can a smart door communicate? What is the story of a smart door? Door, DOOR, smart door. What is the story of a door? Can anybody tell me? Let me see. Opens. What it is, opens and shuts automatically, opens and closes the door, it recognizes our face and opens. See, these are all automations you are talking about. Think about what can a door tell to people. It has to connect to internet. For doing these things, open and shut automatically, open and close the door, it recognizes our face and open. I'm not naming the names. Vasvi, Sharishma, Vindhya, through sensors open and close automatically. You are still thinking on the automation scenario where we have a sensing and automation. Think why it will be called, it is automatic door. Why it will be called IoT door? How it is becoming IoT? Door can take pictures of robbers and send them to our phone. This is a part of the application. Okay. Okay. Let me take you normal in a normal scenario. Okay. this. So what is happening here? If you talk about machines, okay. So a machine, a door, what all things a door can say. Door can tell you how many number of people have come in, who has come in. It can communicate. You have mentioned those things, but I'm telling it from a very generic. How many people have come in, who have come in, what time they have come, how long they have been there. Okay, so these are just 4 things I'm just saying, that these things are there. A door can tell you these things, right? So, and it is smart. Okay, chalo, let me take it to a smart thing. We have, for things I've written smart home and smart city. So why things are smart? What is the difference between an intelligent thing and a smart thing? Who is, I just asked this thing, smart and intelligent, a normal question I have. So let me, time of incoming and outgoing. Yeah, I have told this, communicating with the door. Yeah. So now you tell me the answers for what is the thing, how things are made smart. Means like there was a home, now it is a smart home. It was a city, now it's a smart city. How it is? Those are done by computerized. It's Sanjay. Yeah, it's a very generic statement, Sanjay. I need something specific. Why I will tell it? See, a home, we had home automation for a very long time. In US and all, we had a home automation from say 70s, 80s. In India, we didn't have, okay, I agree. But in US, we had 70s, 80s, 90s, we had full home automation, where you can control the home and all those things. Inside, you can switch on the fan with the remote and all those things were there. Smart home can operate by us. No, earlier also homes were operated by us. But what made them, the home automation was that only, right? What made them smart suddenly? Why things have become smart suddenly? What is the difference between your smartphone and your normal phone? Why you say your phone is smart? Updating the technology design is such a way that it does work to make life easier. Yeah, all technologies are there to make life easier for more facilities. These are generic statement. Siri, Sanjay, to make life easier with high features, we have to define features, because when we had those landline phones, a normal feature phone was very high feature, right? So minimal use of manpower. Yeah, that is always the use case for a technology. Okay, let me tell you. So what is the difference between a normal setup and a smart setup, or an intelligent setup and a smart? See, when you become smart, you are saying, oh, this guy is smart or this girl is smart. When we say this when you communicate with people. So things used to be dumb till that time. They used to be dumb. They used to not communicate. Things started communicating in the sense, now if I say a smart home, if I go out of my home, maybe I'm in Bangalore, I go to Mumbai, I can still open my phone and I can see the status of my home. So my home becomes smart because it is communicating to the external world. It is connected to internet, so it uses this information and communication and people skills to communicate its situation. Okay, this thing is just a part. In place of people also is there, information and communication is also there. Then it becomes smart. Like your phone, your feature phone doesn't have internet. Your smartphone has internet. That is the major difference between a smartphone and a feature phone. Okay, now feature phones are also coming with internet, but that's the basic understanding of the main thing. Okay, always connected to internet. Yeah, internet is the major part here. We have to be part of the internet, then only we can understand this thing. Okay. Now, okay. So I think it's clear that what is the difference, how these phases have gone, and they are all overlapping, right? So information communication is still there. People's internet is still there. Things have only added. And things are what? Don't think if a smart, or if a device, if a electronic device doesn't communicate to the external world, it is not a smart thing. It is not part of IoT. IoT, there are two things. Mainly IoT, the thing has to connect to internet. If the thing is not connecting to internet, it is not a IoT. It is simple automation or simple anything, you can name it. For being a IoT device or an IoT setup or Internet of Things, You have to connect to internet. If the thing is not connected to internet, it is not part of Internet of Things. Okay. Am I clear? Any questions? Can you give examples of that? Yeah. So now let's say we say smart city. So what is smart city? Smart city is something, it's not about that your tube light, which is when there's a less the street light, when you have less what do you say, sunlight, or the light, it is evening time, when your sensors detect that there's no enough light, then the street light switches on, right? That is an automation. That is not smart. Smart is something where, let's say, you have a camera which detects people are there, and it has some method in which it is showing up to the world that how many number of street lights we have switched on due to this reason. So it is not about only that it is doing the automation, it is also communicating that automation. So there will be a central dashboard in which a government employee or a person who wants to check out the smart city can see that how many number of tube lights or how many number of street lights are on in the system. How many of them are working properly? How many of them the sensors are correctly operating? All those things will be communicated by these devices. Now, initially what might happen that, let's say, a smart camera which is connected in a traffic light. So it's part of the smart city initiative. So what will happen, this smart camera will take a photo picture whenever someone breaks the traffic rule. Maybe they crossed the line and there was a red signal, they crossed the line, it will take a picture. Now, initially what used to happen that these pictures were saved. Monthly basis, they used to be, not in India, we didn't have that. We directly jumped to the smart part. We didn't have this earlier setups. Earlier setups were like monthly, they used to be taken out. All the videos will be taken out, all the pictures will be taken out, and then fines will be sent. Now what is happening, whenever the picture is taken, this picture is automatically sent to the central server. In the central server, there's a app running, or there's an application running which will take that picture, extract the number plate of it, check out the directory for the registration number, and send a message to the person that this is your fine amount. So this is something in a very smart manner where different things are connected, they're communicating. There might be a human interface also in this. Means a person can be there to check it out, and he might get a, see, at the end of the day, it is coming to a person only in the mobile phone, right? So a person is also part of this. I think the example is clear. A smart home example also I have given that earlier it was just automation. You had a remote control inside the home. You used to just press the remote control, or you are a little far from the home. You just press the remote control. You are in the vicinity. So window will open, door will open, light will open, like that. Light will close accordingly. Or some sensor will be there which will give some input, and accordingly it will work. But the smartphone the smart home becomes the example when you are outside the vicinity of the house. You are not in a wireless range of the house. And then also you can see what is happening, you can control. So that becomes the part of the thing smart. Okay, I have given you two examples which I have written here. Okay, so now the basic part is the difference. I will be in this page for some time so that you can check out and see. Okay, so next is the difference between IT and IoT. I will not show this page first. I will ask you guys, what is your thinking? See, why I'm doing this exercise where I'm asking you guys these questions is so that I can understand, and you also clarify yourself that what all thing you think about IoT and smart things. And if there's a wrong understanding, I can correct it. And maybe you can also give me good ideas. I don't know. Maybe. Yeah. So what is the difference between IT and IoT? Anyone? What do you think? What is the difference between IT is your information technology and IoT is of Internet of Things? It's information. Yeah, that I'm also telling. I'm not asking for the abbreviation, Aman. It's IT and IoT. So this becomes a very important part because IT is very popular among us, right? Information technology is very popular. IoT is catching up, right? Anyone else? Difference between IT and IoT? Just bindas, you can just send up whatever you think so that I can rectify or I can understand what your thinking is. IT refers to computer technology in general, and IoT refers to communication between devices. This is Shurapto. I can, if I'm mispronouncing your names, I'm just sorry from the starting itself. Divya Singh is saying IT is a technology, IoT is an application of Internet of IT. Okay, IoT makes use of, Aradhya is saying IoT makes use of IT. Yeah, this is a valid point, a good point. IT works on data, IoT works with machine data, IT process data, lot of communication using Internet, both related to Internet. Yeah, both related to Internet, right? Sadik, Surapto, sir, correct pronunciation. Thank you. Kienaga, IT is tech used to gather info, but IoT is part of IT. Yeah, Naga, correctly, you said it correctly. IoT, Harshal, IoT is a network of physical objects that are embedded with sensor. Okay, very techy answer, Harshal. Vidya, IT is sharing information using technology. IoT is IT to make things smart. Yeah, Bindya, I think I can give you around 90% correct as an answer. This is what our answer should be. IT focuses on infrastructure, network, and software. Nishant, OT controls physical world. Should IoT control physical world? It manages data. Okay. I think we are getting into the right answer scenario. I will stop it now. So IT, as Bindya said, IT is sharing information using technology. IoT uses IT to make things smarter. Okay, so IT is the big brother here. Okay, IT is the big brother, which, see, because if you see this one, information communication comes first, right? This is the first thing which comes into the scenario in IT, which remains in the thing also, which remains with people also. So we still say it as information technology because that's the term it was coined initially, and from there everything whichever comes into the internet domain, we put it into the IT domain. Okay, so definitely IoT is a part of IT, but in a general understanding, it has a little differences. I've just noted it down here that IoT refers to a network of interconnected physical objects of things that are embedded with sensor. Somebody wrote this one only. Okay, IT encompasses a broader range of technologies that involves use of computers. Okay, so this is the focus point. So IoT is like more physical objects, bigger parts, everything which is there with making networks, softwares, databases, everything in a bigger way. That is IT. IoT is a smaller part of it, which has sensors, software, and technology. Again, sending data using the IoT system only. Nature and components, if I say, IoT involve physical devices. IT also involve physical, but it has more on the software part, and physical for it is more servers, infrastructure, computing infrastructures, and things like that, storage and all. Okay, data generation and usage, if I say, it is IoT uses very less data. Okay, IT handles various forms of data. IoT is very small. It just gives you sensor data. That's it. Maximum sensor data and control data. You will not have much more things than that. But in IT, you have all the kind of data. Your in-person information data, application data, storing and securing and processing, everything is there. Applications, if I say, similarly. So it is more on the IoT application is more on the side of your how you work in the monitoring of a smart things like smart city, industry, healthcare, smart healthcare, smart agriculture, things like that. IT is a bigger part. Again, it is focused on more on the administrative part of it, software development in a bigger way, network administration, cybersecurity, databases, and things like that. Communication and interaction, IoT emphasis on communication, physical devices. IoT is and IT is involved tasks such as data sharing, collaboration, remote access, video calling. Those kind of things are more into the IoT and IT differences. I think you have a basic picture clear that what is the difference. Anybody can tell me? Vindhya, thank you, sir. Thank you. IT store information, IoT for data moving. Okay. Not exactly a physical world, it manages data and application. Sharishma, I think, yeah. So IT and IoT difference, it's not, see, you will not be, there's no clear difference. I will tell you directly, there's no clear definition where you can differentiate, but it's just the mindset which we have. When we are talking about IT, we think about software design, we talk about physical infrastructure for things and in a bigger scale. IoT is just a part because people see information and communication is the bigger umbrella. Under that, people are there. Under that, IoT, Internet of Things are there. So it is like that. Okay. 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 So this is something which is very important, where we talk about relevance of IoT in today's world. Basically, this is the major part or the major focus in which IoT revolves. So efficiency and automation. Okay. Efficiency and automation is data collection efficiency. Okay, efficient data collection and analysis and automation. So let me give you an example. Okay. See, rest all things, if I say, I will just go through them one by one. But tell about data-driven insight. This is something which we will discuss. Smart cities, smart healthcare, home automation, industrial Internet of Things, environment monitoring, agriculture, retail and customer experience. I will give you examples for each. Okay, I will try to from my my own experience in working in this field. So I will give you example, efficiency and automation. So what was happening? We were working in a poultry hatchery. Okay, so hatchery is somewhere you have eggs and you put the eggs and you get the chicks at the end. Okay, they are like incubation boxes, big incubation boxes. So we used to have. I'll just go to the chat part. So if somebody is saying something, I can see. Okay, you understood what is a hatchery, right? Eggs are hatched in the hatchery. They are an incubation box. In big incubation boxes are there where temperature and humidity is controlled so that egg say chicken hatch hota hai. Okay, so now what is happening there? What was happening? They used to take the temperature and humidity reading. It was there, a small screen was there on the incubation boxes, and they used to take the readings there. So now during taking the readings, every hour they used to, one person used to go around. There were around 150 to 200 devices, incubation boxes, and each they used to go to each and every boxes, and they used to write down the temperature and humidity. Okay, and they used to record it again. They have to feed it, or they will just do take a picture and send it to their supervisor. Like that they used to do. Now what happened? We put our all devices there, so each of the machines will have its own data collection, and there was a network we created. There was a gateway. We will discuss all those architectural level things in the later classes. So what happened in the end of the day, that we created a dashboard in which their higher executives were able to see live always the data. So what happens there? The efficiency increases. How? Because they were taking the data every 1 hour. If something bad happens within that 1 hour, they were having a loss of hatchability rate, which was around 2 to 3% because of that 1 hour gap, and they cannot increase that gap to less than let's say to half an hour because of the labor shortage. So now we were giving them the data every 15 seconds update. So now they have just put one person there who will take the action whenever an alarm is triggered or a message beeps up into his phone from his higher executive. And higher executive also knows in one day how many such alarms have gone up and what is the time in which the alarm was solved or the alert was handled. So he can increase the efficiency. He will know that person how efficient he is. He can retrain him, or if he's not efficient and he's not been able to retrain, he is removed and someone else, more efficient person has been brought up. And the result was they had an increase of hatchability of close to around 5 to 8%, which is huge if you talk about the poultry industry. Okay, so that's one example. So automation was also done because whenever we had something like in a situation, we had some fans there, which whenever the humidity was very high or the temperature was very, not the humidity, the temperature was very high, we used to switch on the bigger fans. So that was a part of the automation. So I think this example is clear for the efficiency and automation. You had a basic idea. I'm not getting any message. Anyone can message me saying that, yeah, you are able to. Yes, sir, CD. Understood. Good. Anyone else? Abdo, Ayush, Thank you. Okay. So clear, na? Efficiency, how we can increase? Because if we do monitoring in a real-time environment or in a real-time situation, we can always do much more than what we normally do. We can take prompt action. We can make people accountable. So these things are very important in the industrial environment and other places also, like real-time automation efficiency. If I say, I was talking about that smart camera, the smart camera which is connected in a traffic light. Now earlier used to be one traffic police used to be standing there. He used to be checking out each and everyone, and if it is the office timings, he will not be able to catch one person or 2% at a single time, right? He will have to catch that person. He has to take a challan. By that time, many people will go away. There might be 2-3 people there, but they will not be able to do it 100%. But if we put a smart camera on the traffic signal and it takes picture of anyone, because it has a sensor which triggers whenever there is a red light and a person is crossing this one. So it is something like this. It is, let's say you have a cam. Yeah, this is a red line. Okay, this is a traffic line. Now your red signal is on. So whenever this red signal will be on, the camera sensor will be activated. Whoever, these are the normal vehicles. Okay. Whoever crosses this line, if this is red and this camera detects someone outside this line, it will take a picture of the vehicle and this can be decoded into for the number plate and a fine can be raised. Okay, so this is efficiency and automation. Efficient data collection. Data collection is also increasing because this camera is continuously recording the number of vehicles which are going here. So you have at the end of the day from this road, how many vehicles go. So government can make swift decisions where it will be more efficient in taking that decision to know that where we can put, we can improve the road condition there, or we can broaden the road, or we should put a flyover here because there's too much traffic. And what is the time of traffic? We can do some diversions of it. So there's not much which can be done. Okay, so there's efficiency, data collection is there, analysis is there, and automation is there. Okay. Okay, I've made this quite clean this up. We'll go to the next thing. You guys are not getting bored, right? We'll discuss a lot in this scenarios for understanding. See, I will tell you one more thing. The idea is not that you can simply make a smart setup, you can send data. This is not the idea of this course. The idea here is you can understand a problem statement, and from there you can go back and understand that what all I should put in my solution to give a final product. That's the idea. Is it clear? So it's the part of this training is also to break the problem statement, because that is one of the major thing with my experience. I will tell you, if you can decipher what is the problem, you are through. Half of your journey is done if you know exactly what is the problem. Because if you don't know the problem, you will never be able to get the proper sensors, get the proper communication system, get the proper automation, get the proper data analysis. Nothing will be done if you don't understand the problem. You are not only working in IoT as a technologist, you are an architect of a solution. So you have to understand the physical things also. That's why I'm not going into tech right away. I'm talking about general understanding. This till now we have not discussed a lot about technology as such. It's a general information on technology, right? You agree to me? You understand what I'm trying to do with this? Some yeses will be good. Sanjay, thank you for the yes. Anyone else? Yeah. Okay. Thank you. Okay, I think I'm understood. So let us go to the data-driven insight. Now, I have already given an example for data-driven. I've given an example for traffic light. So sorry, traffic camera. So with the traffic camera, if I understand what is the frequency of what is the density of the traffic here, I can take actions accordingly. I can, for a long term, I can offer some broadening of the road or some flyover. Short term, I can have some diversions so that I can go ahead with a smoother traffic. Okay, that is something there. Make informed decision, optimize the operation, and identify trends. So these three things which I'm talking about is very important. Like I was talking about that poultry hatchery scenario, right? So in that hatchery scenario, informed decisions, I will tell you. So what was happening, we saw around in night from 2 o'clock to 4 o'clock, we had a lot of fluctuations in temperature and humidity. Okay, so it was happening in particularly out of 150, around 5 to 10 places or 5 to 10 incubation boxes. So what we did is we started interacting with people and seeing that place, that what is the, so it was an informed decision that we understood that around in night sometime the fluctuation happens in a big way. So what we did is we told them to, and it was reducing, the temperature was reducing than normal. So what we understood that there was a problem in the fan. There was a fan, it was not working properly, and due to that time, because the temperature outside was less, that was affecting the inside temperature. Okay, and we understood this by identifying the trends. We optimized the operation. What we did is we sealed that. We changed the fan, and there was a ventilation window which was outside. We just closed that. So that was one of the use cases which we did. Okay, that was a data-driven insight. I have given you 2 examples here. Okay, smart city. So street lights, I've already told you. Waste management system. Anybody can tell me how in a smart city waste management system can work? What can be a basic architecture? 1-liner by anyone? Smart city waste management system. What should it do? What should the waste management system do? Anybody can message? A smart waste management system. Smart cameras to look for piled up garbage. Yeah, that can be there. If there's any waste, can be done. Garbage collection info, smell levels to check. Automatic garbage collection. Garbage collection is okay, but how automatic? Detect the blockage. Okay. See, you guys are still in the sensor world and automation world. Go out of it. It is a more information world also. Information world also is a part of it. Right? Separate wet and dry waste. Okay. That is again automation. How IoT? Smart. We want to make the garbage bin smart. Okay. I will do it. Okay. I think you guys have high loads of technology. That's the problem. Okay. So we have to, when especially working in IoT, you have to think from the user perspective. What is the issue? When we have a smart garbage, this is one garbage bin, this is another garbage bin, this is another garbage bin. Okay. This is the road. And maybe here also we have one garbage. Now what happens? We have a sensor here which senses how much the garbage is filled. Let's say this is full. This garbage bin is half empty or half full, whatever way you say. This is almost fill, almost, and this is totally empty. Now, normally this collection van goes through this route. It will go to the empty, it will say empty. Then it will go to here. It will again return back. It will go to the full. It will again return back. It will go to the, it's just half full. It will go to the full like this, it will go, right? Okay, I will just make the route separately of a separate color so that you can understand it much better. No, this will fully change it. Oh, that also okay. Screen is better. Okay, so now what happens? Now, if all these garbages have a sensor and it sends data to the cloud, where the data is analyzed and understood that this is the first and most important. This has to be collected today. We need not to go to this until it is half filled. This we should not go at all. This also we will go tomorrow because it's not fully filled. And we know by data that how much filling is happening on an average every day. Okay, so we simply, this vehicle goes here, collects this and goes away. It doesn't collect this. Next day when it will come, this will start filling up. This is fully filled, so it will just simply go here, collect this and go. And this full, it will become almost full. Next day it will collect this one. This one will be fully empty. This one will be just empty. This one will be half empty. So the routing will be done through this. So the person will get a map in the morning where making smart city, giving intention to cleanliness, get the information fast. When garbage is full, automatically send the info to garbage vehicle. Not directly. It will not send it to the garbage vehicle. It will send it to a central system which will see all the garbage bins and the statuses which have to be collected today, which don't have to be collected today. They all will be routed through like your Google map you do, right? 2-3 location you just put down. Similarly, it will be put down on 2-3 locations, and from there that pickup locations will be sent to the drivers, and that to that driver who is nearest one. Like what you do in Ola and Uber. Whoever is nearest to you, he's given the SOS first, or he's given the requirement first. Same thing it's done here also. Okay, I think I'm clear. The example is okay. Traffic management we have already discussed. Environment monitoring is direct. Environment monitoring, how it can help. IoT enable optimize the efficiency, waste collection. That's a generic statement, Rishikesh. We have to be more specific. How? See, I have first of all, what are the issues? Okay, I will just take 5 minutes to explain this. What are the issues in waste management? Issue is that sometimes the garbage bins are filled up. What is IoT and Python relation? We'll talk about it, Nikhil. We'll talk about it. First, we are discussing on IoT today. IoT in a generic term. Then we'll go into understanding how we can use Python. See, Python will be more on the language side or on the firmware side, where we design and develop our relationship between devices and information systems. Okay, so that there we'll be using Python. Okay, so here what will happen is we are having a waste management problem where the waste is filling up. We don't know. A person has to go there and check it out. Okay, so that is removed by sensor. Now we know which all places we have the bins filled and what is the shortest distance a person can take to take all the bins. Maybe we will reduce the human labor also here. We'll have more efficiency. IoT helps in reducing time, energy by real-time monitoring of the system. Yeah, IoT is doing that, and when it is giving this data to a IT system, this is making more meaning of the information using data analysis, using your more efficient AI ML techniques. It is going into that direction. Once the data comes in from the real things, the AI ML things can be plugged into the system easily. Okay. Now we'll talk about healthcare. I think we'll take some. Okay, healthcare we'll discuss, and then we'll take a 5 to 10 minutes break. Okay. Okay. Yeah. Healthcare. So next is healthcare. Okay. Thank you. So healthcare. What is happening in healthcare is healthcare. Can you say a smart remote monitoring is very important. So if you see your smart watches and all, they are very helpful, because what they are doing is they are giving you not a fully remote monitoring, but it is at least indicating you that something is wrong, your health is not right, or your heartbeat is higher. But there are remote monitoring setups also, which are like you can put them at home, and it will have all the ECGs and all those things, and it will be connected to the patient. The patient doesn't have to go to the hospital. He will be there resting in home. And these vital data points are always given to the doctor, and doctor can set some parameters or some limitations, some limits. If the data goes, if the values goes higher than that, he's informed, and he can take a prompt action, or he can take a prompt remedy. Maybe a nurse can be there at the place, and he can just remotely monitor. So that is one of the major things which are there. Then you have remote surgeries. Remote surgery is also part of the IoT systems only. That other side we have a robot, and this side we have a doctor who is able to control the robot, and they are doing surgery. It's still not very much popular across the globe, but it is catching up. People are going into that. Health tracker is one of the things. medical equipment management is there. That is also a very important part. And all this, like what happens, there's a inefficiency when, let's say, a nurse takes your temperature, okay, takes your blood pressure and writes it down on her notebook. Then they upload it to, because now everything is online. We want everything, our prescriptions, our reports, everything online. So they will, again, somebody has to do a data entry. So now what happens here, there's a machine, this BP or temperature monitoring machine directly is connected to internet through maybe a Bluetooth or a Wi-Fi setup. And whenever it collects the data, it knows which patient is there because that's there in the database. It sends the temperature and blood pressure data, and that is saved in its database. So there's no false entry, because in human intervention, there's always a chance that there can be a false entry. So that is one thing which is not worked around. I think home automation, these things we'll just discuss one points just after coming from break. So it's like already 7:01. We'll take a 10 minutes break. Pacemaker. Yeah, pacemaker is also not exactly IoT, it's an automation device, more on an automation device. Okay. We'll take a 10 minutes break. Everyone, we'll meet at 7:10. Okay. 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 I think it's 9:10. Is everybody join back? You can start. Okay, so Sumaya told me I can. Okay, back, sir. Thank you, CD, for being back. Okay, I will start again. Okay, so coming back. So let's see. So we have the hardware, home automation. Home automation we have already discussed. We can all imagine it. We have smart thermostats which will tell our temperatures and accordingly switch on our AC or switches on our AC, or let's say it switches on our heaters depending on what kind of climate we are facing. And this switching on switching off happens with the time frame. It knows, the home knows that you are at home, then only it should start. It might even start before you reach home. Let's say you have a smart car. I'm just giving an example. Okay, it's a fascinating world of smart connected devices. Let's say you have a car, which is I think everybody is there. Yeah, I think so. Let me see. Yes. Is there any material for IoT, sir? Yeah, I will be sharing these all. Don't worry. Okay, I will share this all, and whenever we do codes and things like that, we'll share that also. So don't worry. In general understanding. Hear me out. We are recording this. You can again go back. These are all understanding from real world situations. So getting materials for this is very difficult. Just to tell you. Okay. For generic, whatever tech part I will take care, I will definitely give you materials for that. Okay. Not the understanding or analyzing of the problem statement and the product development. Those things you have to just hear me out. Okay. So what happens now? The car comes into picture, and whenever the car is nearing, because car will have a GPS enabled scenario, right? So if your car and your home are connected to a single, let's say a single server, a single IoT backend infra, with which what happens whenever the car is near your home, because of the GPS location, that can be detected, and depending on how much time it will take for the car to reach home. Let's say your AC takes 25 or 10 minutes to make the house the temperature at, let's say, 24 degrees Celsius or 22 degrees Celsius, which is a normal temperature which you will like. So now what happens when your car is nearby and it takes 5 minutes, this AC knows it takes 5 minutes. So whenever your car is at a 5 minutes vicinity, it will switch on the AC accordingly. So you don't have to come down and understand that, okay, I have to switch on the AC, I have to wait for some time. I don't know if you guys are from north somewhere, or maybe in south you have, apart from in Bangalore, we don't have these kind of situations. But across India, we get this kind of situation where you will like to have your ACs and fans switched on beforehand, and cooling, the room should be cooled when you enter. We don't get that, but we all aspire for that. So that is something which home automation gives you. It's more on the fancy part of it, but now, if you see, there are a lot many low-cost devices and low-cost automation which is coming down for home. Smart switches, smart plugs are coming down where you can control these things from anywhere in the world. If you have internet in your home, you have even smart plant monitoring setups where you can have a small kitchen garden and everything is controlled like that. You're away from home, then also you can take care of your plants. Industrial Internet of Things. Okay, let's talk about this in a better way. Industrial, how to link IoT with real time. Please take any short case if possible. I have already done that, Naga. I have already done that for traffic, smart traffic camera. I have already done that for a hatchery kind of a scenario, real time. And whenever you have an alarm it will, whenever the data is breaching the point, or the data from the sensor which is coming down, which is higher than or the lower than the threshold, then what is happening? There's an alarm triggered at the local area. There's also a message which is given to its supervisor if the breach is higher. So things like that with IoT programming. Yeah, we'll do that programming. Don't worry, we'll do that. We'll discuss first. We have to first understand these things, and we'll go into all those parts. Don't worry. Okay. No need to hurry. You have to understand these things very slowly. Tech part is always there. You can always get into tech part, but if you don't understand problem statements properly, you will never be able to become a good IoT engineer. Because if you want to become a full stack IoT engineer, you have to first understand what is the problem. Then only you can give a solution. Okay. Okay. So let's look into IoT, Internet of Things. Okay. Industry Internet of Things, which we call IIoT. So IIoT or Industry 4.0 also. They say it as industry. They also called it Industry 4.0. Just remind me once we are on the second or third day of our class, we'll discuss Industry 4.0 also. Okay, so that you can understand what is from the industry point of view, how it works. Okay. So what is happening in Industry 4.0? Industry 4.0 is, see, earlier used to be having an automation scenario. Maximum there was a screen, a human, they called it as HMI, human machine interface. That is a LCD, which shows all the data and you can select and do things. It's like a touchpad. But what happens? That's it. There's no data going out from that factory. It's all in there. Now, if somebody wants to remotely manage, like I have a factory in, let's say, China. I should not have, but yeah, let's say I have in China and I'm in India and I don't trust my neighbors because it's a far off country. I don't know the culture. So I can do this remote monitoring using IIoT and I should exactly know what the guys are doing there. It's not only cameras, it's all sensors, what the condition of my machines, everything I can monitor from here. All the sensors were already there in the industry. The part which was missing is the connectivity between that data point and the internet scenario. So industry is one of the places where automation was there for a very long time. Okay, automation and sensors were there for a very long time, but the problem was that there was no data coming out of it, or so that we can do analysis and things like that. Okay, environment monitoring, quality control, air control, water quality, weather conditions. These are simple examples you can understand, and everybody can get that. If I have a local weather station in my vicinity, and everybody is broadcasted that message through some app or something, people can all get into that, and even that data can be used for your route planning, that this area is dangerous, the air quality is really bad there, so I should not go there. So those kind of things can be done with smart monitoring. Agriculture is something which we will be discussing for use case scenarios. Okay, so we'll be going through that later on. Retail experience. Okay, these things you note it down. Agriculture, transport and logistic, security and service, energy efficiency is again a generic thing. Retail or customer experience. You have to give me a use case on Monday. Few of you, what can be the use cases for these kind of things, what we can build. Okay, so just note down transport and logistic, security and safety, retail and agriculture. I will not be discussing that. We'll discuss it on maybe for 10 minutes on Monday. You guys go through this. I have given you all the hints in all this. Half of it I have given, the rest half you will explore. Agriculture, how IoT in agriculture, IoT in safety and security, IoT energy efficiency, you leave that. Okay, that's just monitoring of energy and making more intelligent. So this can be use case for this can be your Tesla. You know what is Tesla wall? Anyone? So we will be able to do few IoT projects. Yeah, I will set up one scenario where you will have some kind of monitoring, and from there you will be having a data visualization. So both things will be part of it. Car company. Tesla is a car company. Tesla wall is something which Tesla company, what it does, it makes a battery pack, which can power your home. Okay. Tesla wall. You just search internet Tesla wall. You will understand that is a part of your energy efficiency. So if you search about Tesla wall, you will understand a lot about the IoT behind it. Okay. Power wall. Yeah, power wall also. Tesla power wall. This area. Maybe Tesla power wall. I might be mispronouncing it. It says. Yeah. Tesla power wall. And they have all the roof covered with solar panels. And it powers your home. Okay. It powers your home. So there's a lot of IoT part in that. If you check out some videos of it, you will understand. Energy storage, sir. Yes, it is energy storage. Using IoT, they store power in a normal way. From the solar panel, they're taking the power, they're putting it in but they make it smart. They connect it to their car systems. They connect it. They have a lot of things which are like they will put it on what is the best time for switching on your ACs? What is the best time for switching on your thermostat and things like that. So they do a lot of stuff like that. You can check out. It will be really nice to see. Maybe I will show you a video next time. Or the recharge battery station home. Yeah. I understood. Okay. You guys have understood. You guys got the hint. You can check out videos to understand what they are doing with it. Okay. So I will transport, logistics, safety, security, retail. I want examples for this. Okay. Maybe from the real world. You have to search around and find out a real world scenario. Okay, now we'll be coming to the main part where you guys are very much interested because you are mostly doing engineering and you are all interested in technology. But I will tell you, in real world scenario, it's more, as I'm telling repeatedly, it's more important to understand problems. Otherwise, you will just be a person who will take instructions to what to do. If you want to know what to do, you have to understand the problem. Okay, that is very important. And that is one of the main reasons why we are doing this. In this, we will take you through the journey where everything is, in bits and pieces, everything will be part of your IoT full stack scenario. So we have here, we will not be able to complete the full stack section, but we'll touch each and every part of it. This is a full stack scenario. The full stack is like you take a problem statement and you create a solution. Full everything in between. So you have to interact with users, you have to understand the problem, everything you have to do. Okay, so that is where the full stack understanding here comes. It's not only the technology. Otherwise, you will not be full stack. You will not be able to become an architect. So if you are not an architect in IoT, you will not be a full stack person. Okay. So let us work around on the hardware side. Okay. So if you check out this hardware design, so what are things you are checking out? You are appropriate components, designing circuitry, integrating sensors for data collection, ensuring power efficiency, addressing physical constraints of the device environment. Okay, it says a very generic scenario. Now, how to understand what is the appropriate component? Let's say I want to make a smart plug. Okay, let's say I want to make a smart plug. Now, there are a lot of components which have a huge cost difference. So something like if we have an electric relay into the system, we can get that relay for 20 rupees also. We can get that same relay for 2000 rupees also, maybe more. Same, with the same specification, but not with the same quality, not with the same life. So we have to understand that what kind of market we are handling. So depending on that market only, we can select the appropriate component. So selecting the appropriate component is to understand your environment in which you will be putting up the circuit. Depending, let's say I have to deploy a temperature sensor in a, let's say a temperature sensor where in a fridge. Okay, a refrigerator. Okay, now here my normal temperature is -8 to minus or to 0. That is the temperature you have to keep. Now, to get this specification, what is the first thing? If you are searching a temperature sensor, if I get a temperature sensor which gives perfect value in 0 degrees Celsius to 85 degrees Celsius, will this work? It will not work, right? Will this work? What do you think? I have a requirement of a fridge temperature sensor, with this fridge temperature sensor, the range is -8 to 0 or 0 to -8, whatever way you want to say it. And your temperature gives the best value because sensors have a best range. If let's say I'm using a sensor for human temperature detection. Okay, so my best range should be from 30 degree, or let's say 25 degree to 40 degree should be my best range. It should be highest accuracy here. Not in, let's say, if I'm looking at a freezer thing, then my best range is less than 0. So I have to, for each and every use case, I have to think on that what should be my component. So selecting appropriate component is not like this is the best sensor. There's nothing called best here. It's good. It's high quality. What is high quality? Nothing is high quality. It all depends on the use case. It all depends on how much money we can spend on it. So those kind of things are very important. Now, designing the circuitry, the size of the circuit. What should be the size of your device? Depending on that, you have to think on what is the hardware I am putting up. What is the enclosure I am putting up? What is the type of enclosure I should put up? I should put up a waterproof of IP65 or a 68. So cost-wise, it will differ. So what I should do to overcome that? So those kind of things while selecting the hardware, it is no perfect hardware. In college, you will do it like this. Okay, I can take Arduino and I will take some sensor which is available. I will show a use case. That can be the way for a college level scenario. But in a real-time scenario, you have for each and every sensor type, you have hundreds and thousands of sensor companies across the globe. From there, you have to understand which one I have to select for my use case. Okay, so that is where the problem lies when you are selecting the key components. Now, you have a power efficiency issue. Now, let's say one sensor you're putting in a factory where you have 24/7 power. Power goes also for 5 minutes, there is a generator for that. And now you are putting up a sensor, let's say a weather station, you're putting in somewhere in Himalayas, where half of the time, let's say not Himalayas, let's say in Western Ghats, where almost 2 to 3 months it rains. So you will, if you are putting a solar panel, you will not have proper battery. So your battery backup should be 3 months, 4 months. Otherwise, your device will be off in that time. So these are the kind of informed information decision making you have to do while addressing this. It's not only to design. I can just take 4 components, I can connect and data. No, not like that. You have to understand the physical constraints also. Okay. Now let's go into the firmware design. Firmware design, let's say functionality manages interaction with sensor. So we have a sensor reading, actuator automation, then processing, and then communication. These are the majorly 4 parts. If your device only sense or only actuates, so one part is gone. But processing and comms are common to all IoT devices. Okay. So this is where your algorithm comes into picture, that how I should process the data. Let's say I'm giving an example. Let's say I have a 4G device. Okay. Now I take the sensor reading. Okay. Now let's say what is the time now? 7:27. My device takes the reading of the sensor. Now it starts connecting to the 4G network. And the 4G network is very slow. It takes 2 minutes to connect to the internet. And then it is now time is 7:29. So in these 2 minutes, the sensor data might be different. So what I will do is, I will send this 727's data at 7:29. This data is not relevant now because it's already 2 minutes. So my algorithm should work like, I should first connect to 4G, then I should take the sensor reading and send it. So that my time between reading and sending is minimum. You're getting my point, everybody? How this firmware design and hardware design is very user specific. Okay, so this is the reason why I'm insisting that you have to understand what IoT is rather than just the technologies. You can do hardware, you can get an Arduino, write a C code, put some libraries, and it's done. Yeah, but that precision, that real-time monitoring should be available also. Huh? You are engineers. You are actually enabling that real-time monitoring. What will be happening after real-time monitoring, we know. But how to enable that in a speculated cost, in a speculated environment, We have to understand the environment in which the device is going. We have to understand the price constraints of the thing. We have to understand the size constraints. We have to understand the power constraints. Okay. Yeah, the attendance feedback link is shared. Please you give your attendance and share your feedback. Okay. I don't know, maybe you are getting bored also with this theory part, but you see, connecting a sensor to a microcontroller, sending data to internet using Wi-Fi, these things we'll do all those things, don't worry. But if we don't understand the bigger concept, then we'll not be able to understand the beauty of the system or the problems in the system. We'll not be able to understand. Okay, now after this, there's a firmware design. So this edge computing is a part which is not always there. Second, yeah, this is not always a part. Sometimes your device directly communicates. Let's say your device is a 4G enabled module is there. It directly communicates to the cloud. Cloud is your internet. Okay, your data is directly sent. That can be sent. But in many cases, we have edge computing. Like I was talking about the hatchery, right? Hatchery, we had a edge computing device. So all these boxes, I will just draw. We had all hatches, H1, H2, H3, like this, H4. Okay, and here we have a device connected inside with sensors and humidity sensors. Okay, so it is D1, D2, D3, D4. I'm just giving example for 4. There were many more than that. So they all were communicating using Wi-Fi to my edge device. To my edge device using Wi-Fi. And my edge device was connected through your normal LAN to the router and was sending data. This was my edge device, which can be like your Raspberry Pi. Can be example. It is like a computer. It's normally a computer which can be of different sizes, and there's a router which is like your Wi-Fi router you have at home. Similar to that, not exactly same. So this data is continuously sent. So this is where the edge computing part comes into picture. Okay. Now, okay. Now cloud computing. So these two things can be a part of the system directly connecting to the cloud, or through this also it can connect to the cloud. Okay, edge computing, if there's an edge computing device, then edge computing device will only communicate to the cloud. Rest all will connect to the edge computing device locally using some local method for communication like Wi-Fi, Bluetooth. Yeah, Bluetooth still exists in the IoT world. Bluetooth. We have something called LoRa, L-O-R-A. Just search around what LoRa is, you'll understand. Other things, LoRa network, then normal wireless communications are also there, some sub-gigahertz and all. Okay. Now the last part is the UI and the data visualization. So UI and data visualization can be in many ways. So you can have some website where you have a dashboard. You have a website where you have a dashboard where you are seeing live data like this. Or you might have an app, a mobile app, which will showcase the sensor data and maybe sends you notification. It's going really bad now. So a normal dashboarding is for a generic scenario where you have many devices and somebody is there to see that and control that. App is more for a personalized data format where maybe you have less number of devices and individually you want to take care of them. Okay. Okay. So next we'll talk about a use case. I was already discussing this. So till now everything is clear. It's more on the theory part, but it's clear for you. You have any doubts till now? We'll go into a use case example that how you decipher a problem statement in IoT. Any questions you have till now? Good. No doubt edge computing repeats. Edge computing is like it's breaking the communication part. What is happening? Your hardware is your device, which is connected to the sensor directly. That data is sent to the edge device. I will just show you. Okay. So this was my device one, which had two sensor, temperature and humidity, D1, D2, D3, D4. They all have temperature and humidity sensors. They were sending to this edge device, which is connected through Wi-Fi. Edge device was connected through LAN to my router. Bear with my writing now. To my router, and router is connected to internet through the service provider, let's say ACT or sometimes maybe 4G also. Geo. Okay. Clear? Vishali, clear? Hoping it's clear. Good. Okay. Now let's look into the use case scenario. I have a temperature and humidity control room. So let's say I want to save those eggs only from the hatchery, which were going to the hatchery. I want to save them at some place for some time, and it's a cold room. So what all things I will understand first? I will understand the requirements. I will understand the issues. I will understand the deliverables, and I will design the specifications. Okay. Requirement is that the issue. First, we'll talk about the issue. Requirement are both together. Requirement is we don't understand what time my temperature goes down because we don't have continuously monitoring. There's no person who's continuously monitoring that temperature, cold, temperature, humidity, cold room. Machine is already automated, but still sometimes it goes bad and we don't get that. So because of that, what happens? My eggs are getting bad in a bad situation and they don't hatch after that. So I get a less hatchability rate. So I'm getting a loss. So we have opportunity. Whenever a person says that I am incurring loss because of this, we have opportunity to do IoT there. Okay. So requirement is that I should be informed whenever my temperature and humidity goes beyond my thresholds. A notification, an alarm should be raised there only. A notification should be sent to all the stakeholders who are involved in that cold room activity. And if there is a continuous pattern, my higher authority should be also informed so that the person who is in charge can be held accountable. And with this temperature and control monitoring limits which I have kept, I should be able to do a future analysis where I will backtrack my hatchability rate. Hatchability means whatever eggs I'm putting in the incubation, it should give me chicks. So hatchability rate should increase. Hatchability rate should increase. So what I will see is at what temperature range I'm getting the most hatchability. What all problems are coming down, what is the hatchability? So if I can make a temperature and humidity relationship with hatchability for the later data. Let's say for 6 months or 1 year, he can observe and see best hatchability when he's getting. Okay, so that is what he wants to achieve. Now deliverables is I will deliver him a device which will be installed inside. I will give him a dashboard and I will give him an app. App for individual cold rooms, dashboard for multiple. Let's say he has 20 cold rooms. I will give him a dashboard where he will be able to see, let's say like this. He will be able to see data from cold room, cold store 1, cold store 2, cold store 3, cold store 4, all together. And here you can see the graphs of all together. Now in the app is only for cold store 1. This will be like for the supervisor on the cold store. He will see temperature and humidity continuously. and he will see the logs of this only. He will be able to see logs of all together in a dashboard. Okay, so there will be different people will have different access to the data. Okay. Nishant, clear but not crystal clear. What part, Nishant? If you can be specific, I can repeat it if it is required. Nishant, yeah. So computing, I have talked about computing. I think he will be able to reply to me. If he says something, I will repeat that part. Okay, so we have a requirement, we have issues, we have deliverables, we have specifications. So our deliverables are this. Now specification is what? Specification is my device level specification, my app level specification, my dashboard level specification. Device level means what is the temperature range you are looking at? What is the humidity range you are looking at? App is what you want to show to the user. App ka hai user. User ko what we want to show. You want to showcase temperature. You want to showcase live temperature. How you want to show the logs. What is your real-time graph and your historical graph. So those things for a particular, what all values it should have. What will be your alarm points or the threshold values? Should you be able to change the threshold value from your app, or it should be fixed? Those kind of specifications you have to take. Deliverables and specification you have to create. So these two things are created by you. Issues and requirement are from the customer side. Okay. Am I clear? Example is okay, or I should tell you, explain you more. Wait 1 second. I'll just delete everything up first. Something wrong. Yes. Okay. So anything question? Yeah. Yes, sir. Yes, clear. Nishant, I have not heard from you. Rest everybody is saying it's clear. So assuming it's clear. Okay. So that was the use case scenario. Next. So next day, what we will do is we'll do a communication lesson, that how data is communicated, what all protocols we use for communication, what are basic internet standards for it, and basic libraries and codes for it. And we'll try, if time permits, on the second day only, we'll have a demo for a temperature humidity monitoring device, which is sending live data, and we'll do some work with it. Half of it will be next class, or next half will be the next class. Okay. So now, so you have some assignment. It's not a full assignment type of thing. You have to think on an IoT product or IoT solution, which you want to provide, which all we have discussed. I have given you some fields in this: agriculture, energy efficiency, security and safety, transport. You can even talk about home automation efficiency. Make one-liners, and Amar, can we collect it somewhere?
No, it's just for the practice purpose.
Okay, so you can practice it up, and maybe we'll take around 5-10 minutes. You just throw me those ideas, and we'll select 1 or 2 and we'll discuss it. Okay. Sir, Monday last class? No, we have. This is the start. This is starting only. Any emulator used for this course? Yes, we will be using any emulators. We'll do Raspberry emulation. We'll do some device emulation also. So we'll be doing those device, because we will be working on a use case scenario where you will have a device, emulated device. You will have a emulated or simulated, whatever you say, is your Raspberry Pi and cloud. All these 3 things will have involvement. Okay. And Lakshmi Nivas, no, Monday is last class. No, Monday we have started. We have around 7 to 8 classes more. Okay. Okay. Now, so anything you want to discuss on this part? Okay. Product can be from, let's say, what we have discussed. We were discussing one smart. Don't give my examples only, otherwise it's not good. Smart, like what we did with smart camera. Smart traffic camera, the full solution. Okay. Then you can look into the power wall thing, something on that line, or a similar product, or some solution. The solution can be like what we were doing in the hatchery thing. It's a solution, it's not a product. So there's temperature monitoring happening at different angles, and you have a dashboard and an app. A solution can be like that. Okay, so depending on your use case scenario, you can put up the solution or the product part. Okay, and search around. You will get a lot of good use cases, not then the generic ones. You will get a lot of use cases, and even if it is commercially available, it's okay. Sir, is any hardware required? I will do simulations on direct systems. If you want to use your hardware, you have a ESP32. Mostly we'll be using ESP32 because it will be easy to work around. See how it will be like. I will show you how ESP32 sends the data. Once that is done, we'll simulate that part. Okay, and from there we'll take it from Raspberry Pi simulation as well as from the cloud simulation. So we'll showcase how this data, so that you have some physical form of the device. Otherwise, everything will be simulated initially only. It will not be Saturday, Sunday. No, we have next class on Monday. Okay. Any other questions you have? Any doubts you have for today? I'll just go through once so that if you see something you have not understood or you have any questions in it. Vindhya, no, we don't have class on Saturday, Sunday. Anyone with any other question? Sir, I have Raspberry Pi 3 module. See, I will tell you how to work on a Raspberry Pi environment. For logging in, I will not be able to do it in the class itself for your hardware. If you know how to get into the SSH mode of it, you can directly use that, because we'll be in a terminal part of the Raspberry Pi. From there, we'll be working around. So it can be simulated as if you have also that also. But you should know how to simulate. Is there any software required, sir? Yeah, there will be software requirement. I will give you the list of things which you have to download. Okay, think around it. We'll discuss it on Monday. Good, Akansha. Smart pet feeder. That makes a lot of sense. Pragati, I think it has been shared again, I think, but I don't know what to do. Think. Search around on it. On internet, you can find smart pet feeder, what it does. And maybe we will discuss that, how it will work. Okay. Because you see, you need to, what I discussed, this is your plethora. How you will decipher a product is like this: requirement, issues, deliverables, specification. What you want from it, what are your issues. Then we'll think about what we can deliver and what will be the specifications. Okay. Yeah, Amar has shared it. Pragati, you can take the attendance if you want. You want a vehicle description sensor? Okay. Get into this mode. Requirement, issue, deliverables, and specifications. Sanjay, I have decided to make a smart pet feeder. Yeah, Kansha, we heard you. We hope that you will give some specifications and at least the issues and what you want from it. Vehicle description sensor, I think Sanjona. I'm pronouncing your name right, I think. If I'm wrong, I'm sorry. Vehicle description sensor is something which you have to understand. You have to give me more specifications that what descriptions you want. Not now, maybe on that. Okay. So your thing can be a product or solution like the pet feeder. Like the pet feeder is a product, not a solution. Solution is bigger. Home automation is a solution. Smart plug is a product. It's small. It just solves one purpose. It's a product. If it has multiple issues, it has multiple domains, it has multiple components, then it becomes a solution. Okay. And the solution is very specific normally. Specific to your home, specific to your requirement. Product is generic. It's like the tailored suit is solution, and the ready-made suit is your product, or your jacket. Ready-made jacket is your product, and if you are making it from a tailor, then it's a solution. If you are getting it stitched from a tailor, it's a solution. Okay, I have some more. You spelled is correct. Okay, thank you, Sanjoa. Now, and how this IoT course is useful. Okay, it is for final year project. You can take it for final year project. It's a good thing. Make it with all the components which are there in IoT. It can be a very good. How IoT course is useful. See, if you want to work on the real world scenarios where you have sensors and automation, and it is a great data providing scenario, so you have to have an understanding of IoT as a direct solution. Okay, if real world situation like the problems which I was talking about, in which, see, India is going into a manufacturing overload. Okay, we were not a part of this manufacturing world bus. China was leading it, but lastly, in last 3 to 4 years, we are seeing we are having a huge manufacturing coming to India. So if manufacturing comes to India, automation and IoT will be a very big part of it. Apart from that, people want, we have a huge amount of agriculture, we have a huge amount of agri-allied scenarios where sensors and automation is required to increase efficiency. So if you do that, definitely it's a huge scope for things. Attendance camera, which will scan your face and iris. Yes, that it will do as a product. Now what it will do as an end user? This attendance is taken, it is kept in a database, and then what can be done with it? It's not only data collection, it's the end scenario. What all overall you are changing? Attendance is an issue, let's say. The issue is attendance, that nobody takes attendance properly. And if it is taken also, we don't know it is okay or not. Okay, automatic temperature cutoff in geyser. I hope it's IoT product, not exactly automated. Maybe you have an app which can set the temperature every time, then it becomes a threshold temperature and the time in which the geyser should switch on. Okay. So some ideas for final project. Yeah, we'll discuss that. Once you go through this properly, you'll have huge number of ideas. Don't worry. Yeah, not only operate it, you will set the time when it will be switched on, when it will be switched off. Your incoming for IoT, we have to do coding. Yes, you have to do coding. If you want to make the product, you have to, or a solution, you have to do coding. See, today we have a good amount of time, so you can ask me a lot of questions. From next day onwards, we'll be having a very packed up scenario where you will be busy doing things. Okay. In which app we can do coding? There are different scenarios. In Python, we will be doing, not app exactly, we'll be doing in Python coding. I will show you some C code also. I will not go deep into that, but more on the logic side of the C code I will be discussing when we are demoing the ESP32 temperature control. Scenario for Raspberry Pi and demo devices, we'll be using Python only as a major language. Okay, so I hope you all will be coming up with a product and solution with these 4 setups, where you will be talking about requirement, issues, deliverables, and if possible, specification. Deliverables you have to mention so that it becomes a specification first part, where you know what you have to give. Then we'll go into the specifications, that what all the ranges we want, as we discussed. Okay, that's like a pet feeder. I you can think on that. Okay, these 4 parameters. Deliverables means that what is the final thing you are giving to the person. Okay, what is the final from the solution part or from the product part, what he's getting from you. Okay. Sir, in Anaconda, we can do this, not directly required. We don't require Anaconda for that. We'll do simple Python coding, not much. We'll be more on the understanding Raspberry Pi concepts and your application design, where you have some communication method, you have some storage method, you have some processing of, there's some part of rule engine you will be having. So those kind of components will be there. Okay, I think we can wrap up today early so that you can spend next 10-15 minutes to think on this. I don't think you will be doing that in the weekend. So you can take next around 10 minutes to think around on what we discussed. I will keep this requirement, issue, deliverables, and specifications. You want any other page to be shown to you, or you can share? You can go back to the YouTube link also, and you can check out. Yeah, please fill the attendance and feedback. In next class, we will be doing a demo for data sending. Before that, we'll be understanding what kind of protocols we use for communication in IoT devices, and maybe some code for that. And then we'll have a demo in the end of the class. Okay. And from next third class onwards, third to fourth class mostly, we'll have direct device simulation, then Raspberry Pi simulation. This time, which language to learn is important. Python is good. Python is top language. It's also important to understand the programming logic, which is more important. Languages. See, I myself work in C, C++, Python, JavaScript, and currently I'm using Dart also for creating apps. So I'm working around with 5 to 6 languages, which is quite daunting. But the point is, everywhere the major point is the logic, which is more important. So if you have the logic, you can learn a language very fast. Learning a language is not, if you have good understanding of one language, knowing another language is much easier. So get yourself ready with one language very properly. Next, as and when new languages come and requirement comes, you can always switch. That's not an issue. Language is not the end point. The end point is the logic and the understanding of all the concepts, because all the languages mostly have a similar conceptual base. Oops and all, everything is common. Get WhatsApp group link. Amar, we have any WhatsApp group link? I don't know.
No, there is no any WhatsApp group.
Okay. We don't have, Jay, we don't have any WhatsApp group. Okay, I think next 10 minutes you give yourself. We can end this now, and I'll specifically tell you to spend next 10 minutes to think about products. See, productization of IoT is very important. Understanding of the product development is very important. No, you don't need. I will have my device and I will showcase to you. How's your experience with IoT? Yeah, it's a fascinating thing. If things start talking, things were always dead for us, right? Now they are talking, they're telling about their situations. It's always a good thing. Sir, could you please resend the attendance list? Bunny, Amar, I think you have to send the attendance list again. Yeah, Bunny, it is shared. Amar, you want to tell something to them?
Guys, if you have any query or question for me, please drop in the chat box. Zoom and YouTube people also. I will take it up.
Okay. So we can end the class today?
Yes.
Okay.
I will
Okay,
wait
guys.
for 2 more minutes. If they have any query, then I will take it.
Yeah, totally. I'm ready. No issues. Thank you, Ayush. Please, all of you, just think on product and solution side. Thank you, Nishant. Thank you, Abhishek. Same to you, Nishant. Thank you. Thank you, Sultana. Thank you, Sahil. Oh, you. Thank you to all. Have a nice weekend. Okay. Thank you, sir, for today's class. Thank you. Thank you, everyone. Any question you can still put up, I will still wait and answer it. Okay. If it is for today's class, if it's for the future thing, we'll meet again. Don't worry. Same to you, Aarti. It depends, dear. There's no person called IoT. IoT is a big field now. Okay. So you have n number of components in it. But yeah, definitely the IoT architecture person are the best paid one because they design the full solution. IoT is not just like a technology. Okay, IoT is a very big field. It's like IT. IoT is also a big field. You not name one technology or one way to work around it. And then it opens your door to your AI and ML also in a big way. Because AI ML at the end of the day needs data, right? And IoT is one of the bigger source of data. Okay, guys, we are wrapping up today. Amar, we can wrap, right?
Yeah, sure. Thank you so much. So we'll meet you on Monday.
Yeah.